Welcome to your first video of the new semester. We're going to talk about the mole. The mole is a big unit and has a lot to do with chemistry, and it's very important. It's a measurement of matter, and in today's part 1 section, we're going to be talking about the mole as an introduction. Your objectives for this whole unit are to compare and contrast how the mole is similar to 1 dozen, determine the molar mass of elements and compounds, and then convert amongst the mole and amount of something, the mass of something, and the volume of something. So today we're going to focus primarily on Avogadro's number. Avogadro was a scientist and he experimentally determined a number that relates to the mole. And this is in relation to objectives 1 and 3a. Let's say Mr. Shaw wanted to start eating eggs in the morning as part of a nutritional breakfast. If he wanted to do that and make himself an omelet or something, he would have to go to the grocery store and buy some eggs. Now, if he wanted eggs for the whole week, he would need around maybe 12 eggs if he eats 2 eggs per day. And you can't just go to the grocery store and buy 12 eggs. You would have to buy a whole carton. And we know that 12 eggs is 1 dozen. So if I go to the grocery store and ask for 1 dozen eggs, I know I'm getting 12 eggs. And this is an amount, which equals a certain quantity that we have assigned. And the quantity here is 1 dozen. In the same way, the mole is a chemical quantity. What is a mole? A mole is the SI unit for measuring amount. Like I said, it's a chemical quantity. It's Avogadro's number worth of represented particles. Avogadro's number. So like 1 dozen is 12 of something. 1 mole is Avogadro's number worth of represented particles. And Avogadro's number is 6.02 times 10 to the 23rd. What does that actually mean? It's actually 602 with 21 zeros behind it. And that's a lot of zeros. That's why we simplify by saying 6.23 times 10 to the 23rd, or we call it Avogadro's number, because he's the one that actually came up with this number, Avogadro the scientist. So if we had minions, and we had 1 mole of minions. 1 mole of minions would be 6.02 times 10 to the 23rd minions. Okay, that's the short way of saying it. The long way would be 602 sextrillion. Okay, but we say 6.02 because it's a lot easier. Or we can also say 1 mole, because 1 dozen would be 12 minions. 1 mole of minions would be 6.02 times 10 to the 23rd. Same thing with candy bars. 1 mole of candy bars would be 6.023 times 10 to the 23rd candy bars. Representative particles. Representative particles are atoms, molecules, and ions. So 1 mole of gold, which is AU, equals 6.02 times 10 to the 23rd atoms of gold. We have atoms of gold here. Same thing. 1 mole of water, H2O, equals 6.02 times 10 to the 23rd molecules of water. And these are molecules. We have the same amount, just like 1 dozen elephants and 1 dozen apples are 12 elephants and 12 apples. 1 mole of gold is 6.023 times 10 to the 23rd atoms, and 1 mole of water is 6.02 times 10 to the 23rd molecules of water. Same amount, and we have 1 mole of each of our represented particles. So let's go through what a typical problem might look like if you're going to do some conversions between the amount of something and 1 mole of it. So a problem might say convert 2.5 moles of Na plus to ions of Na plus. And yes, you would need the ES if you're going to do plural of the mole, so 2.5 moles Na plus. Remember, Na plus is an ion. We have to use something that we talked about before called the railroad method. This was used in chapter 3 with dimensional analysis. And the railroad method is something that I said would come back, and here it is, it's back. So in the railroad method, we write the unit from the top, and it goes on the bottom of the next one. So we would write moles of Na plus. And in 1 mole of Na plus, we have 6.02 times 10 to the 23rd ions of Na plus. And so our moles would cancel because they're being divided by each other. Just like a conversion factor of 1 dozen of 12 of something, so 1 dozen is maybe 12 apples. 1 mole is 6.023 or 2 times 10 to the 23rd ions or molecules or atoms. And so we can use that as a conversion factor. So now all we have to do is multiply across 2.5 times 6.02 times 10 to the 23rd. And we should get 1.51 times 10 to the 24th. And we need units with this, so we'd of course write ions of Na plus. And this would be our entire answer. Now if we wanted to go backwards and say it said convert from ions to moles, we would just take, let's say we had 1.51 times 10 to the 24th ions of Na plus, and we wanted to go back to moles, ions of Na plus would go on the bottom in 6.02 times 10 to the 23rd ions of Na plus, there is 1 mole of Na plus. And so now we would have to divide. We multiply across, divide by the bottom. And when we get that, we get 2.5 moles of Na plus as our answer. So we can either use our conversion factor like this, or we can use it like this. And this is back from chapter 3. If you need a refresher, we'll talk more about it tomorrow, but for now, let's go on to our conclusion. Today we started talking about how does the mole relate to 1 dozen, and we began to convert amongst the mole and amount of something using Avogadro's number. What I want you to do now is to try these conversion problems and bring them back tomorrow. One of these may be on a quiz tomorrow at the end of the hour, so it would be beneficial for you to do them so you can get the quiz question right. Other than that, have a great night, and I will see you in class.